Hello, my name is Rob Reynolds. Welcome to Math-073. We're going to begin Chapter 5 today, get our first look at Section 1, and we're going to look at rational expressions. Now notice the first 5 letters of rational spells a ratio, so these are just fractions, and we're going to be looking at fractional polynomials and looking at expressions using 1 and how to simplify rational expressions, how to multiply and divide. But we're going to start this lesson talking about the domain, all the acceptable values. Remember, you can't divide by 0. So a rational expression, again, is any kind of fraction. So all of these are examples of rational expressions. Remember, an expression is not an equation, so that'll be another video. If it's an equation, I would say something like equals 5, and then I'm solving for x or something. But if it's an expression, I just have a fraction standing alone. So we can simplify expressions, but we can solve equations. All right, so the first thing to do is find out where these rational expressions are even defined. And remember, you can't divide by 0. You can't also take the square root of a negative, but I don't have any square roots in here. So undefined values are square roots of negatives, and dividing by 0. There are other undefined values, but we haven't discussed logarithms. You can't take the log of a negative. We'll get to all that later. But for now, we're looking for dividing by 0. So factors of 28 that differ by 3 are 7 and 4. Signs are going to be different. The larger term is negative. If you don't know how to factor, please watch a previous video that I've made from Chapter 4, and then set each factor equal to 0. So this expression is going to be undefined at 7 and negative 4. Let's see if the author agrees. You bet. So again, we're finding not the domain. If I was to state the domain of this thing, it would be, from negative infinity up to the negative 4, negative 4 to 7, and then 7 to infinity. But I'm not asking for the domain. I'm asking where this is undefined at. So I would just say 7 and negative 4. So next we're going to look at how to multiply rational expressions together. You just go straight across, a times c and a times d. And remember, there are all sorts of values of 1s. We could start canceling 73 divided by 73. Any number divided by itself, even x minus y divided by x minus y. That whole thing will cancel. Any number divided by itself will equal 1. Be careful, don't cancel parts of sums, but you can cancel this whole sum with this whole sum to get 1. So, looking at this, you may think that we could cancel all of this and our answer is 4. But that's simply not quite the way that it goes, because that 4x is part of a sum. Now if it said 4 times the quantity, x plus 3 over x plus 3, then I could start canceling. But this didn't even really say to simplify. The real directions here, reading this carefully, just said to multiply to obtain an equivalent fraction. So you could multiply by anything. You could multiply by 2 divided by 2 and come up with 8x plus, here's an equivalent fraction, 8x plus 6 over 2x plus 6. This is equivalent. You could multiply by 3x over 3x. This fraction is equivalent to the original fraction as long as you had a nice value of 1. So any value of 1 would work there. So instead of multiplying by 1, we could also divide by any kind of 1. So that's what gives us the power to cancel. So 9 goes into 9. 9 divided by 9 is 1. 9 divided by 36 is 4. And x squared divided by x, well, x squared literally means x times x. And if I divide by an x, I can cancel one of those x's, and I'm left with 1x left. So I have a 4 in the denominator and an x in the numerator. I'm left with x divided by 4. And the author works that out a little bit differently, but again, 936 reduces to 1/4, and you have 2 x's up top, 1 x down bottom. If you cancel 2 x's, if you cancel 1 x up top with 1 x down bottom, you're left with 1 x up top. So again, you cannot cancel these x's because they're part of a sum. So instead, we're going to try to factor. So I'm going to factor out a 3, leaving me with x minus 4. That's the greatest common factor. Down below, I have a 5. Which also leaves me with x minus 4. All of this cancels and you're left with 3/5. Again, the author works that a little bit differently, but it's the same. Again, don't cancel part of a sum, so I can't cancel those a squareds. You don't want to do 8 divided by 4. You don't want to do any of this. Remember, you have to only factor products. And so if you see a sum, we cannot factor. But we have a technique called factoring that you can get factors. So let's pull out the GCF here. I think I'm going to divide every term by 4a, leaving me with 2a plus 7, because when I distribute that back, I'll get the 28a. And down below, I think I can also pull out a 4a, the greatest common factor, leaving me with a plus 3. All of those 4a's cancel, and I'm left with the answer of 2a plus 7 over a plus 3. Again, the author works that out a little bit differently, but same result. Remember, we cannot cancel x squareds here, so that's the temptation, but we do cancel factors. So I'm going to try to factor the numerator. It's a trinomial. Factors of 15 that differ by 2 are 5 and 3. Signs are different. The larger term is positive, so I'll say x plus, x minus. This is the difference of two squares. X plus 3, x minus 3. Any numerator with any denominator can cancel, and I'm left with x plus 5 over x plus 3. There's the author's answer. So remember, any numerator with any denominator can be canceled. It doesn't have to be on top of each other or over. It can be any numerator with any denominator. Be careful, don't cancel part of a sum. So this is part of a sum. This is part of a sum. All of these are wrong. See how this 3's? Don't cancel part of a sum. So all of these are bad examples. Be careful of those. The key is you probably need to factor. If you can't factor, then you probably can't cancel. And this just says, well, when in doubt, don't even try to cancel because you'll be wrong. So let's see. Let's see if we can factor first. X minus 3 is in the numerator. Down below, I can probably pull out 2, leaving me with 3 minus x. But this is unique because I have just the opposite. Now, by the way, we usually like x minus 3. Whenever I see 3 minus x, it kind of looks backwards to me. So I would encourage you to factor out a negative 2, or actually a negative 1 from this 3x. So let me explain this. If I have 3 minus x, I can factor out a negative 1, and that will actually flip. The negative x goes to positive x, and the positive 3 goes to a negative 3. So you can check that out. If you redistribute this, I'll get negative x plus 3, which is the same. So when you factor out a negative 1, it really just changes. This negative x goes to positive x, and this positive 3 goes to a negative 3. And the beauty of that is now I have an x minus 3 up top and an x minus 3 down bottom. I can cancel those. Remember, if everything's gone up top, you still have something up there. You need a placeholder. So in this case, I still have a 1 in the numerator and a negative 2. But nobody ever writes 1 over negative 2. We'd either write negative 1 half or negative 1 half. We put the negative in the numerator or the denominator, or the numerator or out front. It's seldom in the denominator. But all of those are acceptable solutions. So there's the author's answer. Again, in order to simplify, we can't start canceling until we factor. So factors of 20 that differ by 1 are 5 and 4. Signs are different. The larger term is positive. And down here, a little bit harder to factor. I need to find factors of 3 and 4 because the leading coefficient is not a 1. And again, if you're struggling with these factoring techniques, you need to watch a previous video. I'm looking for factors of 3 and 4 that differ by 11. So I'm going to choose the 3 times 4, which is 12, forcing 1 and 1 together, which is 1, and 12 and 1 differ by 11. So my first terms are 1x and 3x. The most important thing here is I'm doing the FOIL method. So if you look at the FOIL method, after first terms come outer terms. So that means that this 1 goes with a 1. And that's what I'm going to try to find next, is the outer terms. Here's first, so after first comes the outer terms. So the outer terms are 1 and 1 have to go together, forcing the inner terms to be 3 and whatever this says. Well, that's a 3 and a 4. So see, I'm just doing the FOIL method, and I've already got the last terms that just get plugged in there, 1 and 4, but I didn't know if it was 1 and 4, 4 and 1 until I did the outer and the inner terms first. So draw that yellow line to help you. Signs are different. The larger term is negative, so let's see, 12 is larger. So make that negative, make that positive. And then I can start looking for opportunities to cancel. So x minus 4s are gone. This is interesting. 7 goes into 7 once. 7 goes into 21 3 times. So I have a 3 down here. And I think that's it. So be careful to grab all of the terms that you have left. I've got an x plus 5 up top. I've got a 3 down bottom. And I have a 3x plus 1. So you need to write this very carefully. There's the numerator, and the denominator is 3 times the quantity, 3x plus 1. If you wanted to multiply that together, you could, but honestly, I would keep it in factored form because you might even make a mistake multiplying it together. So let's just leave it factored, and the author did likewise. So again, before we can start canceling, we can't do any a squareds like this or anything until we factor. So this is a plus 5, a minus 5. That's called the difference of two squares. This guy factors of 6 that add up to 5 are 2 and 3. Signs are alike, they're both negative, so a minus. Up top, I'm going to try to factors of 5 that differ by 4. Let's choose 5 and 1. Signs are different, the larger term is negative. And I can't factor the a minus 2. Looking for opportunities to cancel, I'm going to say a minus 2s are gone. A minus 5s are gone, and I think that might be it, if I've found everything properly. So I'm left with an a plus 1 in the numerator, an a plus 5, and a minus 3, and I would say that's my solution, and the author agrees. So, be careful. They're really big on reciprocals. So any number times its reciprocal equals 1. So this is the product is 1. I'm not really working this through the reciprocals, but that's a nice lesson. Instead of dividing by a fraction, you can multiply by the reciprocal. So there's that reciprocal property. So instead of dividing by c over d, we can multiply by d over c. So the last couple examples are division. So I would rewrite this as a multiplication problem. But I'm going to factor this guy right here, which is x plus 4 and x minus 4, times, and I'm going to try to factor this denominator and put it in the numerator, because remember, instead of division, I have a multiplication, so I need the reciprocal. So I'm going to put the yellow that was in the denominator, I'm going to put that in the numerator. So let's talk about it. Factors of 8 that differ by 2 are 4 and 2. Signs are different. The larger term is positive, so x plus, x minus. And then I'm going to factor the green and put it in the denominator. So factors of 7 that differ by 6 are 7 and 1. Signs are different. The larger term is negative, so x minus and x plus. And then I look for opportunities to cancel. And I think the x plus 1s, you can't cancel over division, so you've got to get to a multiplication before you start canceling. This x plus 4s are gone. And that might be it. So I think in this particular problem I'm left with x minus 2 over x minus 4 times x minus 7. Again, you might think about foiling that denominator out, but I would encourage you to leave it in factored form so we know that it's truly simplified. Last example, I'm going to try to start factoring everything. So this numerator in the upper left, factors of 2 that add up to 3 are x plus 2 and x plus 1. In the denominator, factors of 4 that add up to 5 are 4 and 1. I'm going to hit times, and then in the denominator, what was in the denominator becomes the numerator, because instead of dividing by a fraction, I'm going to multiply the reciprocal. Factors of 24 that add up to 10 are 6 and 4. Signs are alike, they're both positive. And the numerator goes into the denominator, because instead of dividing, I'm multiplying. Factors of 6 that add up to 5 are 2 and 3. Don't use 6 and 1, because that adds up to 7. Signs are alike. We'll add. and then we start canceling. So the x plus 2's are gone. This x plus 4 cancels with this x plus 4. And that might be it. So, oh, how about the x plus 1's? I think these x plus 1's cancel. So, I'm just left with an x plus 6 divided by x plus 3. And again, you might get cancel happy because you get to canceling, but remember, those are parts of sum, so we can't cancel those x's. I can't cancel the 6 and the 3, so I'm just going to leave this. Oh, could have sworn. Well, I can't get rid of that. Thought I could get rid of it. Okay, don't cancel the x's. Final solution is we're going to leave it. X plus 6 over x plus 3. I hope you found this video helpful. Email me with your questions. Thanks.